Just start talking about what the construction is made up of, how it's made.
Well, it's closed cell foam. So this particular foam product, when it gets wet, if there's a hole that gets punctured into it, it will not absorb any water. It will not extend the weight of the product. Any water that will attach to the foam will dissipate off. It's 100% will not gain any more product or any more weight of the dock itself. The construction, besides the foam, as you can see here, the way that these things are adhered together, people have talked about the fact that they're two pieces and they're going to separate. That's absolutely incorrect. They're adhered together with some strong adhesive, and they're actually also fastened together. Here's one of the fasteners you're seeing right here. Through the entire unit, and then they're filled up with the foam, put under pressure. There's a complete mold that holds this continuous configuration of the product as the foam is expanding. Think of it as like a Great Stuff foam, how it expands and it actually will blow out the surface. That mold will hold it in the exact form that we need it to, and the foam that is not needed in the product is extraculates through the ports that we have in the mold.
Okay.
So the balance will actually extend out.
So then on this end, you can kind of get another view of it, just a cutaway of it. So everything's foam filled all of, and is this true of a wave port?
This is true of the wave port, and the way that the foam is built, if you were to think of that real coarse sugar crystals, if you will, that's what this product looks like. When we put in, we figured out the exact amount of pounds to put in each one of the molds. Then it's put under heat, and when it's put under that heat, it'll actually expand, and it expands into this format right in every one of our products, whether or not it's the island or our ports or our dock systems have the exact same foam-filled product in each one of them.
So then when we've seen, and this has been very, very extremely rare, but we've seen some that have a little bit where they feel like they're soft on the top. They're really only soft in just, it's only up there. It has nothing to do with the foam.
Nothing to do with your foam fill. Nope,
Gotcha.
Nope. What you're seeing there, if you get a soft product, it's due to the fact that somebody didn't add the right amount of plastic in the mold, and so then when these are rotor molded, they're 100% rotor molded. So if you can imagine, this product is continuously rotational molding 100% all the way around. Wherever we need to add more material, we have to add heat to it. So if we get to a small area that is going to be susceptible to be thin, we apply additional heat by using a torch or something in that application, and that plastic will adhere to that location or gravitate towards that location and add the thickness to the mold.
Gotcha.
That's how it's done. So what happened if you've gotten some thinner product, two of the things could have happened. Either number one, there wasn't enough plastic in the mold to begin with, or number two, there was not enough heat. And so all of that plastic went on the bottom and didn't get adhered to the top.
So then some of the other products like Shore Port, that's hollow and no foam. Is this one of the only that has foam in it?
This is the only product, the only floating dock that is rotational and molded that has foam in them. Yes. There's aluminum docks out there that have the foam chambers that are attached underneath them.
Yeah.
But as far as the rotational molded dock sections, we're the only ones out there with a foam filled.
Okay. So when we jump over and look at that, I mean that's completely foam filled.
Completely foam filled. The same exact product as what you're seeing here.
Okay.
As well as the island, as you're seeing over there.
Yep.
The island is identically the same thing. That's all foam filled.
So they can't sink, obviously.
They cannot sink. There's areas on the island, there's areas for water to actually drain out of, because there's so many other areas that we have with the benches on the top that water will actually sit in there. The water has to go someplace. So you'd have to scoop or vacuum it out of where the benches are. But if you can see in the very front by the ladder, there's actually drain holes for the water to drain from the back of the backrest or the tabletop at the front.
Okay.
But everything else is foam built.
Gotcha. So, Rick was telling me about how one time his got flipped over and it got so heavy. So what he was talking about was that these chambers here must have filled up with
He
water.
must have filled up with water. Yeah, there must have been an area where he must have had a cavity or something that this got punctured, and then this whole cavity.
Oh, because that would be it would be sealed, but somehow. I think he told me that they have some small holes in the top for a drain or whatever. But
Could very well be, or if this got flipped upside down and this is under the surface, maybe it came in through the bottom between the glue joint.
Yeah. Okay. So for our sales crew, is there any other? I mean, I think this was really beneficial. Is there anything else that you would say that you might have thought of, or something we should know, or a good selling feature or idea?
Well, one of the biggest selling features that I've had in my shows that people really like when they see this cutaway, and you can see it on there too, it's very easy, is the fact that when you're dealing with selling my dock systems of the shore, the Wave Armor product, is that they're so smooth. There's nothing for the kids to get their hand caught on. There's no way for a kid to climb underneath the dock. There's no way for a kid. I don't know. When you were a kid, I used to hike with my parents and go underneath a regular aluminum dock and walk up to the cliff. You can't do that with the Wave Armor product.
Right.
You can crawl around my product 100%. Your hands aren't going to get cut on anything. You're safe to grab onto.
Not cut or caught.
Not cut. Yep, or caught in any way, shape, or form.
Okay.
And they're extremely stable on rough water conditions.
How about, is there anything to talk about on the bottom, which of course our customers never see, of why is that for? Does that do something for us? He's coming back. He's coming back. He's coming back. Here he comes. Okay.
When you look at our bottom of our dock, it actually shows it quite well there as well. But if you look at our brochure and you see the huge air pockets that are in the bottom portion of our dock, if you can think of it as using an empty glass, and you take this empty glass and you try to pull it out of your dishwater, how it sucks itself to the surface of the water, that's what this suction is doing to your dock. It's the same thing. So when you're standing on the outside width of your 60-inch width of dock and try to stand on this side to pull this side up, it's literally sucking that part to the surface.
Okay. And it's also, I mean, there's some savings of material and there's some savings of weight, I suppose, right?
Correct.
Okay.
And the reason that the bottom portion is all black is because we use 100% reground material for the bottom. And versus brand new virgin material, so we're trying to just save the earth a little bit better that way and use 100% reground material.
So I always thought that the reason why it was dark on the bottom was because it didn't show the algae and stuff. And you're saying it's actually
it's a dual purpose, but
it is a cheaper material.
You can use reground when you're using reground or recycled material, then you add dye to it to get the black. You can never get the nice clear gray material by using 100% reground material.
Okay.
You have to start with reground to get your black, and then we just add our dyes to it.
Okay.
But you're absolutely right. That is the purpose. But it also is the purpose of it. The other, the product is all reground.
Okay. All right. I think that'll help us out a lot.
All right.
Thanks.